Hello guys, this is Virender Singh and welcome back at Milton Tutorials and Toolpath. This is our exercise 1 tutorial number 4th, and in the previous 3 tutorial, in the first tutorial we learned about that the simulation and what the basic concept of Milton. In the second tutorial we learned about that how we can do the job setup and all the things. And in the last one, third tutorial, we learn about the left spindle how we can create the tool path for the upper stream, lower stream, upper stream and lower stream, and how we can synchronization all these tool paths. And in this tutorial we will learn about that how we can create a milling tool path for that one component, because on this one tool path there are some milling tool paths are also available. So we will create some milling tool paths that how we can perform like as a C axis, like as a V axis, and like as in a particular angle. So we'll create tool path, all these tool path in this one video. So we have to start with the step by step. So for that one we have to came on a milling, and at milling mostly in a mill turn we create the tool path as per required, but in a mostly that we create a tool path, these tool paths should be in a 2D. So now the first tool path that we have to perform, we have to perform in the front area. So for that one purpose we will create a dynamic tool path or a dynamic mill. Just click on a dynamic mill. Before we start to cut the dynamic mill, first we have to analyze the tool value. So analyze, we have to click on a dynamic and just click right at here. So it's a 12 mm, so definitely we can use a 10 mm of end mill. So we have to came on a mill, click on a dynamic mill, define the machining region. So I just say defining, this is my machining region. Avoidance region, I just say this should be my avoidance region, and the tool path can become from the outside, and just say okay. I have to came on a tool, select tool, and I just use the 10 mm of end mill. Cutting parameter should be normal, wall stock should be 0, floor stock should be 0. In a linking parameter, odd should be in a normal, and all value I just defining an incremental. And now we have to start to perform this one tool path. I just say okay. If I just say okay, so that time it's just a warning. If I create a general tool path, so that time it should be good. But this is my Milton tool path, so that time a new window is getting blink right at here, and that window is called setup. So this is a new window. We have to learn about a little bit about this, that how its window is getting to be work. So that time when we are performing a milling tool path, so we have to defining right at here that which kind of mill we are doing right at here, and on which spindle we are using. We are using with the left spindle or we are using with the right spindle. We are using with the help of upper stream or we are using with the lower stream. For that, this one machine we have a spindle in the only upper stream, so that time it's showing only upper left or upper right. In case for any machine, if we have spindle in the lower side also, so that time we have to defining that lower left spindle or lower right spindle also, but not an issue. At here we have only upper stream, so we have to define the upper, and the spindle which we are working right at here into the left. And now the milling type which I am going to perform right at here, that is C axis phase. So right at here I just say the C axis phase which I am going to perform, and I just say okay. So now as you can see here, this is my tool path in a perfect and a good way. After that I have to create the drilling for this one area, so I have to go to the drill, just defining first drill, just define second drill, just define third drill. This is my fourth drill, just say okay. Tool, .3, just say okay. Cutting parameter, linking parameter, or it should be okay, and just say okay. Now right at here we have to define again setup. In a setup we have to define what, that is C axis phase. So I just define the C axis phase and just say okay. Now have a look. The tool path is getting created successfully, but now we have to make some modifications. Like as we have to came in a linking parameter, the retract value should be 2 and the clearance value should be 20, and just Okay. Now have a look. That is getting in a perfect way. So as you can see here, this toolpath is getting to be created right at here. So first thing is that is done. The second thing is that is successfully done. In now next step, we have to create the toolpath for this one area. For creating the toolpath on this one area, that we can perform a toolpath that is with the help of a contour. Again we have to select this one area just like this one. Continuous the chain selection, just say OK. We have to define the tool, and this both between the both area is 6 point something, so I am using a 6 mm of end mill. And in a setup we can use previously we are using the C-axis face both time. Now this time we will use axis sub simulation. We have to say the axis sub simulation, and right at here we have to define the rotary diameter. So I just say rotary diameter, and we have to define the rotary diameter. And after that we can came on the all remaining parameters should be same like this, and just say incremental, 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 and just say OK. So as you can see here, toolpath is created, but it is came with this direction. So I just close the lead in, lead out from left to the right, and now it's done. I am going to complete it for one side. I have to create for the other chain also, so I just have to copy and paste parameter, change the direction for the chain, just defining this one right at here. Steps would be, all those parameters should be the same like this. Okay, in place of right just say left, and now it's done. That is getting perfect. So now that is also successfully done. Now we are successfully created the toolpath with the help of this one. We do this for this one, we do this for the C-axis face, we do for the axis sub simulation. Now we have to perform the toolpath for this one area. So for creating a toolpath right at for this one portion, what we have to do, we will create a new toolpath, and that toolpath should be dynamic mill. What do you think? So I just selected dynamic mill, and before selecting this toolpath I have to confirm the tool diameter. So this is my minimum radius, just select this one, and this is 3 point something, so we can use a 3 mm of tool. And now we have to came again on a toolpath that is known as dynamic mill. In a dynamic mill we have to just define the machining, so just select this solid face. If we are defining the solid face, that helps a lot to create the toolpath. It means tool setup is getting automatically, tool angle, all these things are getting automatically calculated. Just like this one, just say OK, came to the tool, select a tool library, and defining the 3 mm of end mill, just came to the setup, and the setup I just choose for this time plain rotation. I don't change anything, and now I have to came on tool cut parameter. All these parameters should be the same like as the previous, incremental, 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 but the entry amount, all those should be same. So as you can see here, the toolpath is getting successfully created. Have a look. Came to the parameter, Z cadence is 3 mm. I just change to the 1 mm, just say OK. Now I created toolpath on this one portion for a single area. Now I want to change this toolpath for the all three. So that time what I have to do, I have to transform the toolpath. So in a Milton, how we can transform the toolpath? For transforming the toolpath, we have to click toolpath transform. We have to click which one toolpath we have to transform. We have to transform this one toolpath. So according to that, that is the toolpath that is plane rotation only, and that we can transform with the help of what we have to do. We have to rotate the toolpath. We have to plan the rotate, or we have to do planar transform. I just say the rotate the toolpath. In a rotary, how much time you want to rotate? 3 times. And what is the angle? It's 90 degree, and just say okay. All set, perfect, and it is going to be done. So as you can see here in this, now we learn about that how we can create all the milling toolpath in a mill turn machine. Now I would like to show you the simulation in a perfect way, just defining or select all the toolpath and just say G1. Once I click on a G1, so what is happening? All the toolpaths are getting to be open, and now we have to synchronization. We have to click right at here, expand the toolpath. What is the synchronization? Last time synchronization, that is the grooving. So I have to say once the grooving toolpath is getting completed, again it have to be came, my main spindle or upper stream have to be came in action, and that is getting to be synchronization. So after that, that is going to be start, and after continuously upper stream toolpath is going to be happen. And now just save this one and launch. Now have a look. This is my workpiece, this is my stock, and just play game. Have a look. Face is done, rough, finish, groove, and now it's time to start the milling toolpath. So first is dynamic mill. Where I use this kind of milling toolpath, have a look. That C-axis is going to be tilting. That spindle is came in a one particular specific angle, and now once it's done, outer it's starting to cut. C-axis is tilting in both positive and negative. Now it's successfully done. Once it's done, my next toolpath will came for the drilling purpose, and now all the drills are successfully done, and the next tool will be came. Have a look. Oh, it's done. Now that is tuck. So now as you can see here, all the things are getting perfectly done. So I hope you will getting idea about that, how we can create a mill turn toolpath and how we can create proper toolpath for the left hand spindle for the milling toolpath. So if you have any doubt or a question, feel free to ask us. See you in the next video where we learn about some new things. So see you.